Okay, so in this numerical example, a uniform rod of mass m is supported by a pin at A, which is this location here, and a spring at B. A spring is attached here. If B is given a small sideward displacement, so if you give it a small displacement here and release, determine the natural period of vibrations. You need to calculate the tau here. So tau is unknown, or the period of vibration here. Okay, so in this case, if you draw the free body diagram, we draw the free body diagram here. We will consider a small angular deflection here, which is theta. Again, we are assuming that theta is very, very small. So if we displace this in this direction here, then the theta dot and theta double dot will be positive in this direction here. And we can see that the spring force will be in this direction here, and which in this case is equal to kx. And because angle is very, very small, so this we can because we know the length here, so we can say that this become equal to L theta, as we explained this in the previous case. So this theta is equal to sine theta, L sine theta. So we'll just write it in this way. In addition to this, the mass of the body will act here. So this is the weight, which is again mg, and this angle again is theta. So again, you can split this into two components. So one will be in this direction here, which is perpendicular to this line here, and one will be in this direction here. You can split this into two components, and this component here is mg sine theta, or mg theta here, because mg sine theta is equal to theta here. Okay, so and now again, if you look at this kx here, again you can split this into two component. One is going to be in this direction here, and one is going to be in this direction here, and again this is theta here. So this side will become equal to k L theta cos theta, and because cos theta is equal to 1, because angle is small, so this become equal to kl theta here. Okay, and this become mg theta, because this component is not important because it's passing through the point O, so its moment is 0. Similarly, this component of the kx is passing through the O, so its moment is 0. So we will just ignore these. Okay, and again, it's important that angle theta is small. So sine theta equal to theta and cos theta equal to 1. So we are just using this assumptions here. Okay, so if you draw the summation of all the moments, you can call this this is our point A here. So at A equals uh, IA theta double dot. This is the equation of motion here, and obviously we are taking this as positive because this is how the direction of acceleration look like. So in this case, you want to calculate the values here. So the moments, which is this MA. So the first force, which is this mg theta, and the total length here is from here to here is L. So then the length from here to here is L by 2. So this will become equal to minus mg, and then L by 2 is the mg theta, and L by 2, and it's negative because it's in the it will rotate this thing in the clockwise direction, and we are taking counterclockwise is positive. And similarly, this force here, which is the spring force in this normal direction, which is KL theta. So again, it's negative because it will rotate this in the clockwise direction. So it's KL theta, and you will need to multiply this with L. So L is this distance here. And on the right hand side, we will have I naught, IA, theta double dot. And now again, you can find this in the table that if you consider this rod here of mass m, length L, so it's I about this point is 1 over 3 ml square. So this is the I for this case. So now you can simplify this equation. So 1 over 3 ml square, and this is the equation here that we have here. So now we can theta double dot is also here. You can simplify this equation now. So theta double dot plus uh, 3 mg plus 6 kl divided by 2 ml here, and theta equals 0. Now if you again relate this equation with x double dot plus omega n square x equals 0, so omega n become equal to 3 mg plus 6 kl divided by 2 ml under the root. And now we need to calculate tau. So tau is equal to 2 pi, which is 2 ml, and divided by 3 mg by 6 kl. This is the time period for this case.